Um, so, thanks for coming, I guess. Today we're going to talk about building distributed graph with Apollo Federation. And maybe before we dive in, some questions for you, just so we get to know you a little bit better. So actually, start with a simple one. How many of you actually know GraphQL?
Raise your hand.
Okay, so I can't see anything. Okay, that's kind of good. How many of you already used GraphQL? Okay, yeah, still quite good, I guess. And how many of you heard of Apollo Federation?
Oh,
okay, yeah, it's like more than expected. But that's good. So because that's why we're here. Maybe just to start with us. Who are we? My name is David Krehling. This guy next to me is Gerwin Brunner. We're both from Vienna, Austria, and we work there for one of the biggest banks in Austria and Central Eastern Europe region. And basically what we're doing there is building a new kind of state-of-the-art web application, replacing an old legacy one. And we try to incorporate GraphQL like from day one into our design. So we got quite a few learnings, and basically this talk incorporates that a little. So maybe let's start simple. What's actually GraphQL? Okay, so I can see it here as well. So I guess most of you know REST, and I guess most of you know like the issues you got with REST, especially when you got like when you have like more complex or bigger applications or systems. You have several issues. For example, if you need data from different kinds of services, you always have to call them separately. You have to get all the data from them. And basically, this leads in a slow network environment to bad performance. And you basically get data you don't want or you don't need to. GraphQL is trying to solve that by putting a data graph in between, which is described in a so-called schema. And basically, that allows you to query several services at once and to query exactly for the data you really need. What's also cool, just like a side fact, you can also put GraphQL as a layer on top of your REST services. So if you can't switch like this, you can really like build the REST service into your GraphQL environment and then replace it piece by piece. So, like I said before, like one of the core building blocks of GraphQL is the schema, which is shared between the client and the server. And basically, it's there to validate all the inputs or the payloads you define in the schema. So every time you make a request, in the GraphQL terminology, it would be a query or a mutation. The schema checks if once the types are proper and if the input or the payload is complete, and if the data is in there or the data you want. Another thing is that it's like strictly typed, so you also have type validation in there as well. The second big building block is the resolver, and basically in the resolver, not all the magic, but lots of the magic happens. Because it's there to basically retrieve data, to process your data, and return your data. So every time you query something, for example, it goes to the resolver, and the resolver returns data to you. And basically, that's the point where you connect to the database, where you connect to APIs, where you connect to other services, and so on and so forth. So maybe like the people that already worked with GraphQL know that issue, that like when it gets a little bit more complex and it gets a little bit bigger, you create this huge monolithic schema, which basically creates a mess. So there are several solutions to that. One would be to use schema stitching, which basically creates a mess as well. because like one of the biggest downside is if you try to separate a schema which shouldn't be separated, you create like lots of overhead code, you create lots of effort, lots of work. The bigger it gets, the more you separate it, the harder it gets to maintain, even to understand, and basically at some point it's impossible to test it. So that's where Apollo came in, the smart guys there, and they created Apollo Federation. Next one. And basically, what they try to do is incorporate some core principles. Basically, the first one, it should be declarative, meaning no schema stitching at all. So you're freed of that. And another thing which is pretty great is that you have a separation of concerns, meaning you divide your schema into several standalone schemas, which then can be referenced to each other. And basically, to bring all of that back together to the client, Apollo created a gateway which takes all those several federated schemas and makes one huge schema out of it again. So basically, for the client, nothing changed at all. It's only on the server side. Okay, so to build up a federated schema, you have several building blocks. We go through this list one by one. Let's just start with entities and keys. So basically, an entity is just just a GraphQL type, basically. The only thing that changed is this add key directive on the right-hand side of the customer. Excuse me. Which basically creates a connection between the several schemas. So by adding this add key field, you create this connection point. And basically what it is nothing else than a primary key. Basically it works the same way as in SQL. So the different schemas, or at the end the gateway knows where this point is referenced. So as soon as you created this entity, which again is basically just this add key directive, you can reference it from different schemas or services. So maybe to go back, just imagine this code example, for example, would be in a schema in the customer service. And the next one here would be, for example, in the order service. So basically everything you do there is just creating the same type again, but putting this extend keyword in front of it, and again this directive, the add key primary key, at the end of it. And that's basically where you just, how do you say it, like reference to the other schema. And basically that's almost it. So all you have to do now is just declare what do you want. So basically, again, just like super simple GraphQL. And for that, you got the other, the other keyword, which would be the external. Oh, I have to drink something. Sorry. Which would be the external keyword. And basically, all the external is doing is it's telling GraphQL, it's telling your schema, in this case the order schema, that the ID is coming from a different schema. So it's not like native to this schema. This might sound kind of weird, like in the first second, but if we go to the next slide, hopefully it makes a little bit more sense, because there are also type extensions, because this referencing between different schemas shouldn't be a one-way street. It should basically go in the other direction as well, because you wanna divide it by concern and not just by type. So you also have the possibility, in this case, to extend a reference type. So basically meaning, again, we are in an order schema. We created the reference to the customer type here. And now we want to add some properties there, because just imagine in the order service, we want to know the number of orders for one customer. I mean, there's no point to add this data to the customer service. It doesn't concern it. So we have to add it to the order service. And that's basically what we're doing here. We just add another prop to a reference type without this external keyword. So GraphQL knows straight away it's like native to this schema. And that way you basically create the relationship between those different schemas. So actually super simple. So coming back to the architecture, actually all you need is like different federated schemas and this Apollo gateway. And basically Apollo is providing you with both of those. Just to give you like a quick overview, how much code you would need to set it up, except the code I showed you already, is basically just this. So instead of inserting your schema into your Apollo server, you just wrap your schema by this build federated schema function and insert it to your Apollo server. So basically that way you just create a federated schema which can like work on its own, which is standalone. So it's basically its own schema. And then on the right-hand side, you see the Apollo gateway, which just brings everything together. So into that Apollo gateway, you pass a list of services, basically just providing a name and an URL where to find it, where to find that service, and that's basically it. And so it's really not tough to set up, and it brings you so much benefits. And maybe to show you the transition from like a regular schema to a federated schema, I will hand over to Gerwin now.
So, enough of the theory. I like to do the insane stuff, which means doing live coding, and if the screen comes up, we'll see how that goes. Yeah, okay, so where do we start here? Okay, let's start with a little bit of looking into the code. So our starting point is simple. We have customers. We have coffee, like espresso or a cold brew. And we have orders, which combine those two things, like customers and coffees, together to basically enjoy the beverage. So that's the simplest schema we could come up with. So we have, as said, the customer, which has an ID, a name, a year of birth. We have coffee, which has an ID, a name, which is the type of coffee, like espresso, cappuccino, and we have a price, obviously. We have to pay for it. It's not free. And then we have orders that combine those and also give us the information when it was bought. Pretty simple, pretty straightforward. Then we have basically the resolvers, and can anybody see, or can everybody see the stuff up there? Yes, no? Okay, that's good. Just to make sure. So in the resolver, basically, you would actually go to a database, to a different API, to whatever, to query the stuff. But in this case, we don't. I just basically hard-coded it here. So we have a list of customers. We have Paul, Mark, and Bruce. We have coffees like espresso, cappuccino, cold brew, nitro, cold brew. And we have orders that merge those two. In the resolver, the same. We can query all customers. We can query all coffees. We can query all orders. And we have this thing here that basically makes orders resolve correctly. So now let's quickly look at GraphQL. GraphQL comes with a lot of implementations of the GraphQL API. So like Apollo provides this as soon as you throw it into the application, you get like a graphical interface. And for those who haven't seen that yet, it's magic. Magic meaning, I just start typing and hey, it suggests like, because it's typed, customers. And from the customers, I probably want to query the name, and then I can run this query and I get a list of customers. Amazing. Then we can do the same for coffees. So what kind of coffees do we offer? And we see a list of coffees. And I can, I probably need the ID of the customer in my application to do something else. So I can add stuff on the go. And that's actually one of the biggest magics, that GraphQL does. It gives you the opportunity to, as a client, to just select what you need. Good. So, and finally, let's do something. And let's take a look at the orders. So we can do the same here, like when was it bought. And we can also dig deep into the customer. Who was it? And we have all the same properties that the customer actually provides as an object. So we can select the the customer, and we can do the exact same thing with the coffee and, the exact same thing with coffee also. So prettify this and display it, and so we have it here. So that's really, 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 really cool. Compared to a REST API, who wants to do the same thing up here with REST API? I encourage you to show me that in 4.5 minutes. Anyway, so enough about how cool that is. So let's do the crazy part. The crazy part is we have looked at the schema, the resolver, and finally there is like this glue magic that comes from Apollo, the Apollo server, basically that loads the schema and the resolver, glues them together in an Apollo server, and then exposes it under an URL called GraphQL, and that's it. That's how the whole thing, that's really literally the only code that does something useful in this application, useful for this example. So, and if we now decide as a company, it's a great idea to split up the stuff, so we make 3 teams. 1 team for customers, 1 team for coffee, and 1 team for orders. And they should do whatever they need to do whenever they want to do it without interfering with each other. If you have just 1 schema, this can be a little bit painful. Yeah, I think we can tell you in a beer session what we mean with painful. Yeah. Good. So if we want to split that up, we basically create something like customer in microservices, which is just a folder. And in there, we do 3 things. We create an index.js. Index.js. Yeah, typing is the most difficult thing. Resolvers.js, and I really understand what the other speaker yesterday meant with it's hard to type here. Good, so we have those 3 things. I go to the existing schema and basically just copy everything and remove the stuff I'm not needing. Because we're dealing with customer here now, I just want to query customer. I keep the type of customer and delete everything else. Save. I do the same for the resolvers. Keep the customer data, or database actually, because that's what it is, and remove everything that we don't need. So that's it. As you already saw here, this is a function I wrote before, which is just the same Apollo server creation that we saw before, this part here, with 2 exceptions. We build the schema first as a build federated schema and use that schema then to start the Apollo server. That's everything. That's the only thing that's changed here. Not true. There's one more thing. I pass in a path because we need to expose this new schema somewhere in this example. You wouldn't need that with a separate, you would kind of need that, but if you really have different code bases, then every code base would have a different thing. Here I just used one server. So the path is here. So we need the index file, and I'm lazy because I can't remember this stuff, or actually I tried to remember it before but failed like 3 times, so I just copied this over here. So, okay, this function basically is just a little bit of glue code for my microservice of the customers, which just initializes the create Apollo server code that we had before and exposes that. So, no magic here. So this is the index that we had before. We can now get rid of the initial full single schema GraphQL stuff, and we just do 2 things. We import the Apollo GraphQL Apollo gateway, and we import the function that I just showed you with initializing the customers. Then I need to define a URL. Oops, and not just an URL, but I also need to do this here. Define a URL, which is GMS, which is GraphQL microservice / customer. Then I call the init customers, which is exactly the method that starts up that specific GraphQL server for the customer. And then I have the Apollo gateway, where I pass in this URL of the customer to basically aggregate that. So we have 2 things now. We have the separate GMS / customer GraphQL endpoint that works as a regular GraphQL endpoint. And now we have the gateway, which is just /GraphQL, which aggregates all the other ones, but we just have one, the customer one, and that's it. So, and if everything works, oh, it does. We can go here and do one thing. We go to GMS customer, and we fail, which is not surprising. Does the regular one work? No, everything breaks. Awesome. Why does it break? Init customers is not exported, so.
Oh, yeah, you have to save the index file.
That's true. Saving helps. It really does. Okay. That was simple, helpful, thank you. So let's see if it, yes. So now we are in GMS customer, and we can, oh, cool, query customers. What a surprise. So, damn it. Wrong key. So, and here's my point. We can query the customers. Yoo-hoo. And also, we can query the customer here. Customers and name. So it's there. Wow. 2 endpoints. One is the gateway. This is the gateway here now. And that one is basically the GMS, the microservice endpoint. I'm going to copy over now from my working example the same thing for orders and customers. Oopsie. So you just have to believe me that I'm doing the same thing as before, so we can go there. Here we got all coffees and the definition of the schema. So we just have to import the same thing here, coffee path, more coffee, and expose it through the gateway in the last step, and see if that works. It does. So the GMS customer still works, and we just on this try to see, oh, we have coffees now. Hey, cool. And we just select the price to see a different, it works. So same thing. And finally, I already copied it. We do this exact same thing for the orders. And disclaimer, this is going to break. Why is it going to break? Because it complains about customer ID is marked as external, but it's not used. Huh? Okay, simple. Because what I didn't do before is in the customers, when I copied it over, I missed one thing. I basically need to say that it's a key, and I already have done that in Coffee. So add key fields ID, which is this, which tells the gateway, hey, this is a thing you can reference. And as soon as I add that, we should be back in business. And we are, and it works. And so now we can try to also select the orders and the order ID. Oops, let's remove these here so we can see better. We remove the order ID. It's there. What a surprise. And we add the coffee name, also there, works nicely. And now we add the customer, and it will break. Haha. Planned for that. Okay, so why? Because we miss the other part. And we take a look at the resolver, and in the coffee resolver we already have it. And now I'm putting it over. This is the second piece you need, besides the key for reference, is the way to tell the local service that if some other service comes along and asks you for a customer, in this case, how to do that. And it's the __ resolve reference method that you need to implement for that type, and voila, it works. Good. That's it. Just final words.
Yeah, maybe just I just put together like a short list, which basically some more advanced features you can do with this Apollo Federation. So, for example, you can not only like go for one primary key, but you can do several ones. You can even do like composite primary keys. So, like a combined key has to be there, and so on and so forth. If you're like really interested in all that stuff and want to go into more detail, we got some references here for you. Basically, the first one is the blog post published by Apollo, which this talk basically is built on, and then oops, there's a typo, and then the Apollo documentation. And if you are interested in the code, there's also the link to a repository for this demo we just showed you. So if you want to go into like a simple example and have the code right away, that would be it. So basically, at this point, we're done. Thank you for listening. And yeah.
If you got any questions, find us. We will talk for beer.
Perfect.
And now.
Ah.